2006 number 3 reads, an object moving along a curve in the xy plane is at position x of t, y of t at time t, where dx over dt is equal to arc sine of 1 minus 2e to the negative t, and dy over dt is equal to 4t over 1 plus t cubed for t is greater than 0. At time t is equal to 2, the object is at point 6, negative 3. Part A asks us to determine the acceleration vector and the speed of the particle at t is equal to 2. Acceleration is the derivative of the velocity. Therefore, all we need to do is take the derivative of dx over dt and dy over dt. A of x is then equal to 1 over square root of 1 minus 2 to the 2e to the negative t squared times 2e to the negative t at t is equal to 2. So all we need to do is plug 2 into this equation. So it's 2e to the negative 2 divided by the square root of 1 minus 2e to the negative 2 squared. So you're going to get 0.396 for a of x. Likewise, in order to find a of y, we need to use the equation. We need to find the derivative of dy over dt, which would then equal to 1 plus t cubed times 4 minus 4t times 3t squared, all over 1 plus t cubed squared at t is equal to 2. So plug that into your calculator, and then you're going to get, so that'd be where you plug into, and you're going to get 36 minus 8 times 12 all over 81, which would equal to negative 0.741. And so that's a of y. Now the acceleration vector would just be 0.396, comma, negative 0.741. The equation for speed is the square root of dx over dt squared plus dy over dt squared. In order to derive this, take the equation for arc length in regards to a regular function, which would just be the integral from a to b of the square root of 1 plus dy over dx squared dx. Now change dx into dx over dt times dt, and then change dy over dx to dy over dt over dx over dt. And so then we get the integral from a to b of the square root of 1 plus dy over dt over dt squared times dx over dt times dt. Now you need to take out the dx over dt squared on the denominator of this equation, and so you're going to get the integral from a to b of dt over dx times the square root of dx over dt squared plus dy over dt squared times dx over dt times dt. Now the dt over dx and the dx over dt are going to cancel out, so that you can get the integral from a to b of dx over dt squared plus dy over dt squared dt. Now, since speed slash velocity is just the derivative of the distance or arc length, let's take the derivative of this, and you're going to get the equation for speed, which is the square root of dx over dt squared plus dy over dt squared. Now, put in the functions for x prime of t and y prime of t into the equation for speed, and then plug in 2. And so you're basically just going to get the square root of arc sine 1 minus 2e to the negative 2, and square that, and then plus 8 divided by 9 squared. So you're going to get 1.208, which is the speed of the equation at t is equal to 2. Now, you're going to get 1 point for the acceleration and 1 point for the speed. Part B asks for the time t when the object is at the point where there is a vertical tangent. The expression for the slope of the tangent line is dy over dt over dx over dt. In order for the tangent line to be vertical or to have a slope that does not exist, the value for dx over dt has to be 0. Thus, you need to set dx over dt to 0, so it would be inverse sine of 1 minus 2 e to the negative t is equal to 0, and since I have a t at 89, I can solve for the value of x by using my solve function, which can be found if you press F2 and then 1. So it would be the arc sine of 1 minus 2 e to the negative x is equal to 0, comma x. And so then you're going to get 0.693, which is the value for t. Now, you're going to get 1 point for setting x prime of t to 0 and 1 for the answer. Part C then tells us to determine the expression for the slope of the curve. As said before, that would just equal dy over dt over dx over dt, which is so m of t would be 4t over 1 plus t cubed times 1 over a inverse sine of 1 minus t 2e to the negative t. Now, we need to also find the limit of this. So for the first part, divide both the terms on the numerator and the denominator by t cubed, which would then equal to the limit as t goes to infinity of 4 over t cubed divided by 1 over t cubed plus 1. In the long run, that would just equal 0. Now, you need to find the limit of the second part, which would equal to 1 over sine inverse of 1. So therefore, when you multiply these equations together, it just so the limit as t approaches infinity of m of t would equal to 0 times 1 over sine inverse of 1, which would then equal 0. So you're going to get 1 point for the m of t and 1 for the value of the limit. Part G says the graph of the curve has a horizontal asymptote y is equal to c. Right, but do not evaluate an expression involving an improper integral that represents this value c. So normally, when there is a horizontal tangent, horizontal asymptote, the asymptote is over here, the graph is either going to oscillate over and under the asymptote, or it's going to just go over or under the asymptote. And so regardless, the limit as t approaches infinity of x of t is going to equal infinity. If this is the case, then the limit as t goes to infinity of y of t would just be equal to the antiderivative of dy over dt. And that would equal to, since you have to take the initial value, the initial case of the limits, so it's going to be negative 3 plus the integral of from 2 to infinity of dy over dt times dt, which would just then be equal to negative 3 plus the integral of 2 to infinity of 4t over 1 plus t cubed dt. And so you're going to get 1 point for the integrand, 1 for the limits, and 1 for the initial values to be consistent with the lower limit. In order to practice problems similar to this one, you could look at 2009 number 3, 2010 number 3, 2011 number 1, and 2012 number 2, which all deal with parametrics.